Section 4.4 continued. Evaluate each function, sine of 210 degrees. This is going to revolve around you being able to draw a reference triangle and label it in the correct quadrant. So if I rotate 210 degrees, 90, 180, 210 takes us into quadrant 3. Reference angle here is going to be 30 degrees. This whole rotation was 210. Again, it's 30 degrees past 180. And now label your sides based upon that. -1, √3, and 2. We are asked only to find the sine of this. Sine is opposite over hypotenuse, -1/2. Cosine, -5 pi over 4. When you're doing these radian measures, think of where we're at. This would be -pi over 2, but let's write it with a denominator of 4. So that's -2 pi over 4. I need to go farther than that. If I go to here, that's -pi or -4 pi over 4. I need to go farther than that. If I go up to the top here, that's 3 pi over 2 or -6 pi over 4. So -5 pi over 4 is going to take us in between these two into quadrant 2. There's our rotation of -5 pi over 4, which means the reference angle here is pi over 4. Label the sides, -1, 1, and √2. We are asked only for the cosine. Cosine is adjacent over hypotenuse and rationalize. Tangent, 5 pi over 3. 5 pi over 3. Pi over 2. So when we go to begin rotating here, 5 pi over 3, you can think of this a couple ways. Pi over 3 is 60 degrees. 5 times 60 is 300. Or if you think in terms of radians, which the more you can, the better off you're going to be later on. 5 pi over 3. If I go all the way around, I've gone 6 pi over 3. If I go halfway around, I've gone 3 pi over 3. Down here, that means that it's going to take us into quadrant 4, which we would know from the 300 degrees as well. So here represents our rotation of 5 pi over 3. Our reference angle, we know if we went all the way around, that would be 6 pi over 3. So this reference angle here has to be pi over 3. Once we label that, label the sides. Across from pi over 3 is -√3. We are looking only for tangent, opposite over adjacent is just -√3. Secant of pi over 2. Pi over 2 is a quadrantal angle. Remember a quadrantal angle? We label the ordered pair only. It's 1 unit from the origin, so that's going to be at the ordered pair 0, 1. We can get the sine and cosine directly from the ordered pair. Cosine is 0. Sine is 1. Secant, remember, is the reciprocal of cosine. So the cosine of pi over 2 we know is 0. Reciprocal of that is 1 over 0, which is undefined. Let theta be in quadrant 3, and the cosine of theta is -1/4. So we know our triangle's in quadrant 3. cosine of that angle is -1/4. That's adjacent over hypotenuse. Pythagorean theorem to find the missing side. Leg squared plus leg squared equals hypotenuse squared. 4 squared is 16 minus 1. This has to be -√15. So the sine of this angle is going to be opposite over hypotenuse, -√15 over 4. Tangent, opposite over adjacent, -√15 over -1, which is just √15. Find our angle theta such that theta is between 0 and 360, and the cosecant of that angle has to be 2√3 over 3. Cosecant is the reciprocal of sine. So between 0 and 360, there are two times in which sine is positive. All students take calculus. Sine is positive in quadrant 1. Sine is positive in quadrant 2. Cosecant, hypotenuse over opposite, reciprocal of sine. We're not going to recognize that triangle, so we need to derationalize this. Let's multiply by √3 over √3 and simplify. That's 2 over √3. And now if the cosecant is hypotenuse over opposite, that should be two triangles that you recognize. The reference angle in each of those triangles has to be equal to 60 degrees. So now the question is, what is our angle theta going to be for those two? Well, the first triangle represents just a rotation of 60 degrees. Our second one represents, though, this rotation. How far is that? Well, if we went all the way or halfway around, it would be 180. We go 60 less than that, so that's going to be 120 degrees to rotate to get to that terminal side. Letter B, find theta such that theta again is between 0 and 360. So once again, the first thing we need to do is decide which quadrants we are going to draw the triangle in. All students take calculus. Tangent is positive in 1 and 3. Tangent is opposite over adjacent. Opposite over adjacent. Should recognize this triangle as being a 45-45-90 triangle. So now we need to find the two rotations for those terminal sides. First rotation is just 45 degrees. Second rotation, we go all the way to here, is 180 plus 45, or 225 degrees to get to that. Cotangent theta equals -√3. Triangles first. Cotangent is the reciprocal of tangent. Where's tangent negative? All students take calculus. Tangent is going to be negative in 2. Let's try this again here. And 4. Cotangent, being the reciprocal of tangent, is now adjacent over opposite. So if I go adjacent over opposite, adjacent over opposite, you should recognize this triangle as being a 30-60-90 triangle. The reference angle in each one of these triangles has to be 30 degrees. So now to answer the bigger question, what is theta equal to? First rotation to go from our initial side to there is 150 degrees. Second rotation to go all the way to there is 30 degrees less than 360, so 330 degrees.